Hola. Okay, this is 10.7. It's called elasticity of demand, and we've kind of already worked with the demand function, but we're going to do a little bit more. Okay, so first, let's just practice finding the elasticity of the demand, and then we'll figure out what that actually means. But right now, let's just focus on the math. Okay, so if I want to find the elasticity of demand, E of P, you'll be given something that looks kind of funky. It looks like X equals F of P equals this. It's got so many letters in it. Okay, but let's look at how to find the elasticity of demand from your 10.7 tricks. It says find the X equals FP function by solving for X. Oh, and it already is solved for X. Look, X equals blah, blah, blah. Okay. So we didn't have to do anything for that first step. Second step says find the derivative. Okay, this is us. Okay, so we're going to find the derivative of this F of P. And the derivative of 6,400 just goes away to 0. The derivative of negative 4p squared, you take the 2, bring it down in front, and you get negative 8p. Okay, so we just did step 1 we didn't have to do. We just did step 2. Step 3 says multiply the derivative by the letter negative p. Distribute if needed. So what we're trying to do here is we're trying to build this formula up for E of P, which is the elasticity formula. And to get this formula, we have to take the derivative and put it on this top right. That's why you see this little tick mark, F prime P, and we just found that, F prime P. So we have this top right. The bottom is just F of P, and that's what they gave us in green, F of P equals, the only other thing is I need to multiply it by a P and a negative, or you can just say multiply it by a P and slap a negative on the outside. Either way. Okay, so to find the elasticity of demand, the capital E of P, the formula is negative, then a bar, P times F prime of P, all over F of P. Okay, well, our F prime of P is this negative 8P. So negative 8P. Then our F of P is what they originally gave us, 6,400 minus 4P squared. But then I need to multiply something by this negative P that I haven't touched. So I think I'm just going to multiply the top. It's either you multiply the top by the negative or the bottom by the negative, but not both. I'm just going to put it in the top. Okay, let's see what we get. This gives me negative times negative is a plusative. 8p times p is p squared. So 8p squared. All over the same bottom. Hey, we just found the elasticity of demand. The only thing is, if you look at all three of these numbers, you might see that you can reduce them. So if you can divide every single number in your problem, go ahead. I think we can reduce by maybe a 4. So let's do it. We're going to have capital E of P equals 8 divided by 4. 2p squared, all over 6,400 divided by 4. 1,600 minus 4 divided by 4 just goes away to like a 1, or just 1p squared. Either way, this is our elasticity function. Whoa. Okay, let's do this next sucker. First, we're going to find the derivative. Okay, so the derivative of 83 is just go away because it's a constant. The derivative of e to the p, What? Okay. Usually we have something like e to the x, remember that? And the derivative of e to the x is just e to the x. Yeah, okay. As in, if I have f of x equals e to the x, the derivative, f prime of x, is still e to the x. It's weird. E to the x is weird. Okay, but on this problem, we don't have x's. We have a p, but it's the same thing. It's saying if we have f of p, that just means instead of all these x's that I've been writing, they are going to write the letter p. They are going to write the letter p in the air. P in the air. So if I have f of p equals e to the p, the derivative of anything with an e is the exact same thing with the e. Just like the derivative of e to the x is e to the x, the derivative of e to the p is e to the p. Don't panic. Okay, so the derivative of this 83 goes away. This minus 0.5 just gets brought down. And then the derivative of e to the x is the exact same thing. Or e to the p is the exact same thing. E to the p. Hey. Okay, now let's use our formula for the elasticity. It says E of P equals negative P F prime of P, the multiply dot in between, all over F of P. And let's go ahead and plug our goodies in. We're going to have negative P multiply our derivative, which was up here. Negative 0.5 e to the p. All over f of p. And f of p was this original sucker with the 83 in it. Okay, now all we're going to do is kind of squish this up and multiply it. On the last example, we have a big old normal p and a big old normal p, and that made p squared. On this example, we have a big old normal p and a little p in the air. Those don't multiply together. So here, our e of p equation is just this negative p and this negative 0.5. And then this e to the p. But in math, we put everything in a certain order. In math, we put the number first. When things are multiplied, we put the number first. Then let's think about this. Negative p times negative 0.05 is actually a positive 0.05. Then we put the regular letter p. Then we put the crazy thing with the e at the end. So this looks like 0.5 pep. But p and e are normal size. This p in the air is an exponent. And then we're all on top of 83 minus 0.5 e to the p. And then if I could divide all three of these numbers by something, I would. Like on the last one, I could divide 8/6404 by 4, so I did. But here I have 0.583. And 0.5, yeah, so I'm just gonna leave it like this. Okay, let's go down to these suckers. So far all we've done is the math for how to find the formula for elasticity of demand. Now, we're gonna use this formula to figure out whether the demand is elastic, inelastic, or it has unit elasticity. And if we look at this little either of these charts up here, it describes what happens when you have a certain type of elasticity. So for example, if we have something elastic, then as the quantity demanded changes by a larger percentage, then so does the price. That means when more people want the product, the price is gonna go up. Yeah. Okay, whereas if we look at something called unit elasticity, it says that the quantity demanded changes by the same percentage as does the price. That says that when the amount of products people want is when it has unit elasticity, the amount of products that people want, that they demand, is correlated to the difference in price, and they're equal. Then we have inelasticity, and that's when the quantity demanded changes by a smaller percentage than the price, or the total revenue decreases. Let's look at this little picture for a minute. Okay, first, it says the price elasticity of demand is a measurement of the change in demand for a good or service in relation to the change in price. So, price elasticity describes the change in demand that the public wants. So maybe the public wants more toilet paper. That's a change in demand for a good or service in relation to a change in its price. So maybe during COVID-19, the American public wanted more toilet paper, and then maybe the price increased. Something happened like that. Okay, so let's look at this chart. This is an example of a difference in elasticity. If we look at our price portion, it's saying that my price goes up as if you look at the bottom piece, as my quantity goes down. And then this is another picture that describes the same thing. It's saying that if you raise the price of a product by like 33%, then the amount of products sold that are demanded by the public are actually going to go down by 50%, because no one wants to buy a more expensive product. So as you raise the price of something, less of your products get sold because less people want to buy it. Whereas if we look at this sucker, this is talking about a decrease in price. So if I decrease my price, well, let's think about this. If I make my product cheaper, that means that a lot more people will buy it. And that's what this says. As our price decreases, there's an increase in the quantity that the public wants. So as the price goes down, more people want to buy the product. Yeah, okay. Okay, so let's go back to this problem. It says, first we have to find the elasticity. So the elasticity is that E of P formula that we've been using. E of P equals negative P times F prime of P all over F of P. And then let's see here, we're going to take negative P and we're going to multiply it by the derivative. Well, the derivative of this is 145/20, that goes away because it's a constant. And then the derivative of negative 40p squared is bring down the 2 in front, and we get negative 80p to the subtract 1 all over the original p. Okay, now we don't even have to clean it up from here. From here, we're going to plug in this p of 10, as in maybe the price is $10. Okay, and we're going to see what happens to the amount demanded by the public, the amount of the quantity of products that we sell. We're going to see what happens. So let's plug in a t. We're going to have E of 10, plug in a 10. So we're going to have negative 10, multiply, plug in a 10, parentheses, negative 80 times negative 10, all over 145/20 minus 40, parentheses, 10 squared. And I'm just going to go slow. I'm going to do all the top at once, then all the bottom. So the top is negative 10 times negative 80 times negative 10. Whoa. I put too many parentheses. And I got negative 8,000. Now let me do the bottom. 145/20 minus 40 times 10 squared is 10,520. Okay, now let's divide those. Negative 8,000 divided by 10,520 is negative 0.76-ish. We don't really have to worry about rounding because I just want to know what's up with this number. Okay, so to figure out whether we're elastic, inelastic, or have unit elasticity, we look at this number we just got. It's negative 0.76. It's called our elasticity coefficient. So if we're looking at this top right table, our elasticity coefficient, this is negative, as in it is smaller than 1. So let's look for the part of our table that says smaller than 1 or less than 1. It's this bottom sucker that says we're inelastic. And that means that if the price increases, our revenue is going to increase. Whereas if the price decreases, our revenue is going to decrease. Okay, let's do the same thing, but let's plug in 45 products this time. So we're using the same formula, only we're going to say E of 45. So we're using the same derivative I found in part A. I'm just plugging in 45 now. So I'm going to do all the top at once. And I got negative 162,000 all over negative 66480. Then I'm going to divide these. And I get 2.43, and it's okay that I don't round perfectly on this sucker because all I really want to know is this number bigger or smaller than 1, or is it 1? Well, this number is bigger than 1. So when it's bigger than 1, that means greater than 1. It's elastic, and as the price decreases, the revenue decreases. As the price increases, the revenue decreases. As the price decreases, the revenue increases. So this sucker is elastic. Okay, let's do a big boy. Okay, this is kind of the same thing, only they want you to start from the beginning. Okay, so let's say I give you this equation, P plus 0.002x equals 40, and I want to know what x is, or I want to know what the demand function is. And the words you see might say express in terms of P or express x as a function of price P. Either way, that just means get x by itself. So let's get x by itself. I'm going to subtract over the P. Goodbye, P. And I get 0.002x equals 40 minus that P. Okay, then I'm going to divide by that decimal. And you get x equals, this big thing. I'll go ahead and divide if you want me to. I can either leave it like this and type it in, or I can go ahead and divide. Like 40 divided by 0.0002 is 20,000 minus, but then for the P, be careful. This is a pretend 1 on that P, so I'm going to divide 1 by this decimal. 1 divided by that decimal. And I get 500. So be careful on that P. If you're going to divide like me, you need to do 1 divided by that number on bottom. And I get 500 and then P. So the point was to get X equals, well, we did. X equals this. So this represents the demand equation based on the price. Okay, now it says, what's the domain of this? Well, a hint, I think we've done this before, is to plug in 0 for the letter X and solve for P. Or I think we might have put this in our calculator and looked at what the last X-intercept was. Either way, it doesn't matter. I think I'm just going to do it this way, where I plug in a 0 for the letter X in this equation. So instead of X equals yada, 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 I'm going to have 0 equals 20,000 minus 500P. And then now we have to solve for P. That means get P by itself. So I'm going to pick up this 20,000 and I'm going to subtract it over. And you get negative 20,000 equals negative 500P. Then to get P by itself, it's still multiplying with that negative 500, so let's divide. And you get P equals, I think that's like 4 or something. Maybe 40? Oh, 40, okay. So, this is saying that once we hit a price of 40, my graph no longer makes sense in the real world. So for my domain, in the real world, we want our smallest price point to be $0. We don't want it to be negative, because how do you make someone pay negative for the price of something? So in the real world, the smallest possible price is $0. So 0 less than or equal to P, less than or equal to, and then now, the largest price that we can have before we start losing money is 40, like $40. So in the real world, my domain would be 0 to 40, as in I only want to charge something in between $0 and $40. Anything outside of that, and I'd be losing money for my revenue or my profit or whatever. Okay, let's go to part C. It says find E of P, the elasticity of demand. Okay, we know how to do this. Yeah, we just did it. E of P equals negative P times the derivative all over the same thing. So another way to write this is to say negative P times the derivative over before the derivative. So let's see, we're going to have negative P times, let's take the derivative of that X equals equation from part A. The derivative of this X equals equation from part A, the 20,000 goes away. A number and a letter just go to the number. So negative 500P just goes to negative 500. So we just found the derivative. It's just negative 500. All over whatever we had before the derivative. 20,000 minus 500P. Okay, let's clean it up. The top can multiply to a plusative 500P all over that same bottom. And then you might notice at this point that every single number has a bunch of zeros on it, as in we can probably reduce it. So let's reduce by 500. So on top you get P. On bottom, I think we already found that. It was like 40 or something, minus another P. So this is our elasticity of demand function. Okay, now let's see part D. It says when P equals 20, what is E of P? Well, Let's plug in a 20 and see what happens. Okay, when I plug in a 20, I'm going to have P over 40 when I plug in a 20, I'm going to have 20 over 40 minus another 20. And that gives me 20 over 20, which is just 1. That's weird. Okay. Well, let's see if this is elastic, inelastic, or unit elastic. I plugged in a 20 and I got 1. Well, when it's equal to 1, you have unit elasticity, as in the total revenue is unchanged, as in the quantity demanded changes by the same percentage as does the price. So this would be unit elasticity. So since we equaled 1, it has unit elasticity. Now it says when P equals 24, which is technically a 10% increase, what will happen to E of P? Well, let's plug in 24. We're going to have 24 over 40 minus 24. And I think that's 24 over 16. And if I divide that, I get 1.5. Okay, let's look at what happens when my elasticity coefficient is 1.5. Well, it's not equal to 1 anymore. Now it's greater than 1. So, since it's greater than 1, it's called elastic. And when the price increases, like ours did, we had a 10% increase. When the price increases, the total revenue decreases. So on your homework, I think it'll say something about if something has a 10% increase, what happens to the revenue? And you just say the revenue decreases.